Hello world! Welcome. Today we're going to talk about computer vision. So let's begin. First thing I want to give a shout out is I'm a big fan of Sentdex. I got a lot of the ideas, the Python code, and how all this works through his YouTube channel. You could check it out here, and he also has a website for all the code here. So today I'm just going to reiterate my interpretations and what I've learned, and maybe give a little additional ideas of what it meant for me. And then if you like this, go to our club on Saturday, and I'd be happy to do questions and answers. That's where you also learn a lot, and maybe I can help you get started. So what we're going to do today is image recognition. And we're going to use a module called Pillow. So first thing, I wanted to help describe how does a computer actually recognize images. So what this is very useful in the world today, as we look at our data being provided on the internet. 10 years ago, you had a lot of text-based data, such as Wikipedia. Well, now with social media like Instagram, everybody's uploading photos instead of writing. But there's still a lot of value if you think about a picture's worth 1,000 words. So there is a ton of information that can be captured from an image. And if you look at a lot of the things that, for example, Google is doing, they are capturing, doing image search. So you can take a photo and it can search the internet and tell you what that photo is, or tell you more about what's in the photo. For example, who the person is, or what text is inside that photo. So I've been really interested in computer vision. And today is my first video just to kind of describe it to others in the group. And the first step is to really understand what it is doing at a basic level. And then as you get more advanced, you can get into how to be more complex. So the basic level we'll start with is pattern recognition. And then I'll describe the neural networks. So pattern recognition here, you can basically see we're going to compare pixels to pixels. In my example, we're just going to do on and off, or black and white. We're not going to really do much of the gray, but we're going to do very basic. So what I have for us today is we're going to do a basic number, and this is what they've used in OCR days. So we're going to start with a number 9. So I'm going to draw this, and then I have a data set that was provided, and it basically has 100 different numbers, 0 through 9. But what it's going to do is analyze pixel by pixel, and this is an 8 by 8 pixel. I'll just make it easy for this example. And then in the data set, we're going to compare it to other numbers. So let's just say we have a 1, and we have multiple versions of a 9. And so what you're going to do is you're going to say this pixel and this pixel, these are basically activated, these are not. And then you're going to compare it to this one. Oh, okay, that one's the same, but the rest of them are not. And you're going to see that these are similar. And from that, you're going to actually see that you're going to have a higher success rate of these numbers. Therefore, your higher probability is going to be a 9 and not another number. So that's pattern recognition. And that's what I'm going to show you today. But furthermore, if you want to get into more complex images such as people or colors, more advanced colors, you'll want to use neural networks. And neural networks is, you can use similar pattern recognition, but you're going to do this in layers. So we're going to just do a few layers here. And inside the layers, you're going to have the neurons. And these are basically just weights and measures that you're going to modify your model. And let's use the number 9, for example, again. And we're going to break it up. So in this layer, we're going to analyze just straight lines. And this layer, we're going to do curves. So maybe we're going to break this up, and we're going to analyze and piece together the curves. And then this layer, we're going to do maybe a shape. So here, we're going to have a circle. And so we're going to analyze it here, and this layer, this layer, this layer, and this layer. And then we're going to have our output. So then again, we're going to have 0 through 9. And it's going to be more accurate that way because it has more to compare against. Now, where machine learning comes in is, as you can see, you're going to have thousands and thousands of models or formulas to run through. Data is testing, training sets to run through. Where machine learning comes in is you actually can improve the performance and increase the data. So let's say you'll need to tell the computer whether it's doing poor or it's doing well. And where you can do that is through a formula. If it runs through and the outcome is low, let's say closer to here, then it knows it has to improve the model. So it continues to run until it gets a better result. And once it starts getting a better result, say over here, then it knows that it is actually started learning. So then you can start to add more data and it'll run faster. And the more computational power that you're going to need. So that's a neural network in machine learning, and it's just more advanced and complex than what we're going to show. So let's go on to the example. So here's what we're going to do. First, I'm going to draw a number. So in this case, I have a number 9. And then we're going to compare it against the data set. So here's the example data set on this side. Then we're going to run a Python code, which I'll run through here in a minute, and then plot it on a graph. So you can visually tell, for example, here, that it's most likely a 9. So that's a result. We're going to get that back. All right, if you want to follow along, here's what you'll do. You'll install Python. You're going to use pip to install the libraries, matplotlib, numpy, and then pillow or Python image library. Then you'll download the data set of image files and then run the Python code. And I did a follow along in IDLE. So let's take a look at the code and run the example. All right, so in here, we're going to start up the top. Here's our import of libraries that I just talked about. You're going to do that. All right, then the next block of code here is going to create basically our test data. So for example, here's our test data set. We're going to append to it. We're going to have a range of 1 to 10. That's basically numbers 0 through 9. Then we're going to create what we call numbers we have. Then we have a for loop. And then in here, we're basically going to start splitting the numbers. So let me explain that. So like I said, we have 8 by 8 pixels. And we'll just make this simple again. We're just going to draw a box here, and here's a 9. So in here, you can see that this one is going to be activated, and this one, anywhere that has a number in it. So how do we distinguish? We're going to make this very simple. So in these boxes, not activated, those are going to remain white. These boxes are going to actually have color in them. So if you're familiar with how that works, it's called RGB, or red, green, blue, red, green, blue. And with black or white, it's pretty easy. So you have 255, 255, and 255. That equals white. And then black is 0, 0, 0. So you're basically just converting these to numbers. So with that, all of our data, our test data, is going to be thrown into a file, into numbers, so we can compare it against. So if you open that up, you can see here's our test data set. So the way that this works is you have 10 ones, we have 10 twos, we have 10 threes in each line. Okay, and then across here is each pixel. So we have a pixel here, this one's white, this pixel's white, this pixel's white, this pixel's black. And you're going to go across all 16 pixels. So that's one number, then the next number, and the next, and the next. And then what we're going to do is when we create a number, it's going to be one line. We're going to compare our one line against all 100 lines here, shown here. So that's essentially what we're doing is we're creating that file of our test data set. And then we're doing some manipulation of it by splitting it and converting it to a string, which I'll share a little bit more with you on how that works. So the next part is the threshold. This function of the threshold. And essentially what that does is, let's draw the number 9 again. And let's zoom in on the pixel here. Let's say the pixel's like this. Here's a pixel here. And what the threshold does is it says, okay, yeah, this definitely is activated, but this one is partially activated. So what do we do with it? Maybe this is a gray area. So the computer, we wanted to show that this is activated. But you could, let's say you barely touch this one here. And what you could do is you could say, well, this is only partially, maybe 5%. So we could actually average that and just make it white. But this one here is covered by more than 50%, so we can make that one black. So threshold, what you're doing is you're pushing that threshold. So you might have a little jagged corner here, but that's better than jagging all the way here and skewing your image. So you're just going to jag a little corner here and then your corner here. So this is very fine level. If you zoom out, it won't look to that level. So that's basically what we're doing here, is doing the averaging out and reducing the threshold. So basically making it black or white by doing this. If you follow down here, so this is our white pixels and this is our black pixels converting. All right, let's keep going down here. So next function, we're going to find what number is this. This is basically the number that we are drawing. So again, we're going to open the array that we have stored. We're going to load it in the file. We're going to store it in a NumPy array, make it a list and string. And now we're going to try. We're going to run the try function. So here we're going to again split, and basically what we're doing here, back to the, here we're basically going to take out these portions of it, and then we're going to basically only grab the number sets here. Okay, and then in here you can see we're basically running through each pixel and then we're appending that onto there. All right, so let's keep going down here. Now what we're going to do is called a counter method. So what a counter method does is, let's say in our example we have a 9, we have a 9, 9, 9. This is just, we'll just say 5. A counter is going to say you have 3 9s and you have 2 8s. So then you can basically say, okay, there is a 60% chance that you're going to get a 9 and a 40% chance that you're going to get an 8. So the higher probability that is a 9. So a counter method is basically showing you the string results. Then what we need to do is actually graph that so you can actually see it. So that's what we're doing here. We're just going to start the graph. So we have our x-axis and our y-axis. Sorry, x and y, and we're going to start plotting that. So here is the coordinates, and there's our starting points and a row span, call span, graphing. We're going to center it, and then set the location and plot and show it. And then here is where we load the image. So basically, we're going to have the numbers 0 through 9, and we're going to basically, whatever comes as result, so in this case it would be 9, and we would get a 9 as a result. We're going to graph that. All right, so let's go ahead and try to run it. So here is the number I'm going to input. Just so you have an example, we're going to clear it out, and I'll draw a new number for example. So let's go in and draw the 9. Hopefully my 9 will work. All right, we'll save and run it. See what the result is. So as you can see, the counter is basically giving the string. Now we're going to plot it. So it's currently running. It didn't get over a 400 score, so we're going to have to try it again. It did, as you see here, 397. It did win, but not enough confidence. So let's try and redraw that one. Let's see how it does. Now, one of the things, the reason it probably didn't do it is it's either shifted too far left or right, and there's a way you could center that if you wanted to do that. All right, let's run it again. Well, 9 is a little bit, oh, you know, I didn't save it. That's what I needed to do. So we have the same results there. Okay, so there, now it did detect it's a 9. 9's a little bit harder. We can do something, we can do an easier number like I had before. We can do a 7. Let's try a 7. That one should work pretty easily. Yep. So you can see it detected a 7. Now let's just for fun, let's do another one. We're gonna do just a 1. Make it easy for ourselves. Should be a pretty easy straight line. Well, let's see how it does. Yep, there it goes. So just to show you that it works, it's kind of fun. You should try it out. If you have questions, you can comment, but even better, come to our club on Saturday. And don't forget to check out the resources online. It's Sentdex is the guy's name. I follow a lot of his work. He does great explanations, so check it out. All right, see you next time. Cheers.